My name is Tom Staub. I'm a Partner Solutions Architect with AWS. And I'm joined today by Pallavi Sharma from our EC2 team and Stephen Wright from Liberty Mutual. And we're going to talk about SQL Server on AWS. But before we do that, I want to talk a little bit about Windows on AWS. Something maybe a lot of you might not be aware of this already, but it's a public study was done, and there are almost twice as many Windows servers on AWS as compared to Microsoft Azure. And as you can probably imagine, a lot of those Windows servers are running SQL Server, which begs the question, why? Why are people making that choice? And we're going to try to answer that along with some other questions today. But we're going to start there. I'm going to do this in what I call like chapters, right? So our first chapter is going to be that why question. Why are people choosing AWS for their SQL Server workloads? And after we talk about that, we'll talk about, well, what are your options for where to run SQL Server on AWS? So you have a couple options, different ways to configure it. We'll talk about that. Then we're going to talk about the how. How do you get to AWS? Once you've made that decision, I want to run SQL Server on AWS, you got to know how to get there. So that'll be the next thing we talk about. And then finally, anybody who's worked with SQL Server a lot knows it's not a fire and forget solution. You got to continue to monitor it, manage it, and we'll talk about what some of the options for that, as well as what we can do to help you with that. So to answer the why question, there are various things we could talk about. Sometimes when I do these presentations, I talk about the global footprint of AWS and how every one of our regions has at least 2 availability zones and the benefits of that. We will talk a little bit about that as it relates to high availability and disaster recovery. We talk about security, our partner network. There are a lot of reasons, but for a lot of people, it comes down to price. I want something that's going to be cost effective and it's going to achieve my goals. And in another study, it was determined that SQL Server workloads running on AWS are much faster and much less expensive compared to running those same workloads on comparable systems on Microsoft Azure. So why is that? Why is AWS faster and cheaper, and what are my options? Again, once I make that decision. And that leads to this second question, where can I run SQL Server? And you're going to have 2 options. The first one, Amazon EC2, Elastic Compute Cloud. That's virtual machines, right? This is where it's a self-managed virtual machine. You can license SQL Server along with that, but you also have the option to bring your own license. But the core differentiator here is that this is a self-managed virtual machine. Whereas Amazon RDS is our relational database service. This is a managed service. It's not just SQL Server. Today we're talking about SQL Server, but RDS, we also have database engines for MySQL, Postgres, Oracle, and MariaDB. And we also, of course, have Aurora, which is our cloud optimized versions of MySQL and Postgres. But again, today, the focus is on SQL Server and the differences between running SQL Server on EC2 and RDS. Each one has its own advantages, but you can see right from the very beginning, the first difference is in the versions. So for RDS, you'll notice it starts with 2012, ends with 2019. Of course, everything's ending with 2019 now with SQL Server. But why does RDS start with 2012? Well, SQL Server on RDS is always a license included licensing model. So when you launch an RDS instance with SQL Server, the SQL Server license is part of that. You're not going to bring your own license for this. Microsoft, as of July of this year, they stopped general support for 2008 R2, and obviously earlier than that, they stopped general support for earlier versions. So along with stopping general support, we can no longer offer a license included option for versions prior to 2012. So that's why for RDS it starts there. Well, I mentioned earlier you can do license included on EC2, which is why EC2 it says all with a couple asterisks. If you want to do license included SQL Server on EC2, you're at that same limitation for the version numbers that you are with RDS. On EC2, you could choose to, for 2017 and 2019 anyway, you could choose Linux or you could run it on Windows. But either way, if it's license included, you're at 2012 and newer. But the reason for the all is because EC2 does support bring your own license for SQL Server. And if you have a license for SQL Server 2000 and you have the media and you want to upload it and install that, you have that option to install SQL 2000, 2005, etc. on an EC2 instance. Again, it's self-managed. That brings me to my next point. Excuse me. Oh, one other thing about that on editions. Same thing happens with Developer Edition. You could install Developer Edition. Essentially, it's a free SQL Server, but it's only for test and development environments. You can install that on EC2, but there is no option for Developer Edition on RDS. In terms of high availability, right? That's the first area where I'm gonna focus on this. What do I mean by a managed service with RDS? And you'll see it a couple times here. I talk about managed backups, and we manage the patch management for you for both the operating system and SQL Server. On the RDS side, we're going to do a lot of those things for you. On the EC2 side, since it is a self-managed virtual machine, you're going to be doing all of that. So let's say you want high availability for SQL Server. Maybe you want to do an availability group, maybe a failover cluster, mirroring. You have a lot of options, right? RDS, you have a great option. You don't have to do anything because it's auto. What you have to do is check a box and say, I want to run multi-AZ. And we'll talk a little bit later about the benefits of that and what that means. But that's all it is for RDS, is simply just checking a box saying, yeah, I want to do this in multi-AZ, and it's going to be high availability across 2 different availability zones. So for RDS, the first thing you're going to pick is, you got what instance type do you want? And essentially it's a choice. It goes back to that price performance that I talked about at the beginning, right? So if you choose an M instance, that's your sort of general purpose instance type. If you want an R instance, you get more RAM. And we have some newer instance types we're working on to provide even more higher RAM capability. For the storage, anybody who's familiar with Elastic Block Store, you're probably familiar with GP2 and IO1. GP2, as the GP stands for general purpose, is where people usually start. And then IO1, of course, for your high intensity workloads. Now, whether it's SQL Server or anything else that you might be running, we don't always know exactly what we need in the future. And even if we did know, you don't want to launch an instance today with the compute power and the memory and the storage to handle everything you're going to need 10 years from now, because for the first 9 years, you're kind of wasting money. So we have to talk about scalability. That's another great thing with RDS is when you want to scale, you have the option to scale the compute, scale the storage, scale the memory. You have these options. And again, because it's a managed service, we're going to make that as easy for you as we can. So you choose how you want to scale and to what degree you want to do that, and we'll do the work for you. So if you have multi-AZ RDS, for instance, you already have that high availability, you have that second instance in another availability zone. So of course, if you're doing this on premises, how would you do this yourself? You would probably want to upgrade your secondary instance first, because it's not going to affect what you're doing day to day. And then you do a manual failover to that secondary once it's set up, and now you have the higher performance, and then you can go ahead and upgrade your original primary. It's the same way you would patch those systems as well, right? You're going to start with the secondary and then go to the primary. But the advantage with RDS is we're going to do all that for you behind the scenes. So we'll go ahead and do all of that. We'll handle upgrading both the secondary and the primary, any failovers necessary, and it's all part of this managed service. And with that, I want to introduce Pallavi to come talk about what your options are with EC2. Pallavi?
Thanks, Tom. So, as Tom was saying, with RDS, you don't have to worry about managing your SQL Server databases, as AWS does the heavy lifting for you. But if you want to manage your SQL Server databases yourself, and there could be several reasons to do that. For example, to meet your unique replication or disaster recovery requirements and so on, you have the option to deploy it on Amazon EC2. With self-managed deployments, however, there are several things that you need to think about, such as licensing, performance, high availability, etc. So I'm going to take you through these considerations in the following slides. So let's talk about licensing first. So as was called out previously as well, you have the option to either purchase the license directly, a license included instance from AWS, or you can bring your own licenses with the appropriate software assurance and license mobility included. You can find a detailed FAQ for licensing on our website, aws.amazon.com/windows, and that'll answer your deeper licensing questions. After that, you choose an instance type from a variety of computing platforms. So as you see on this slide, like it lists a few of our general purpose options, compute optimized, memory and storage optimized, and so on. But like, for example, a lot of our SQL Server customers, they typically choose memory optimized instances to maximize RAM for large databases. But we understand not all workloads have similar needs, right? Some need high networking performance, and some require a huge RAM size. So EC2 offers instances to meet a variety of your needs. For example, this slide shows you the versatility of the R5D family. Now let's talk about optimized CPU option for BYOL scenarios. Why do we offer you this? This lets you get a better control of your CPU to memory ratio. So for your own licenses, optimized CPU allows you to purchase a larger instance type for more RAM and potentially faster storage or networking, and then reduce the core count to match your SQL Server licenses. Next, let's look at the storage options that go along with these instances. So as you can see here, AWS has a variety of storage options, each with its own advantages and features. For example, AWS Snowball can be used for large-scale data migrations, and S3 and Glacier have their place for backups. But for SQL Server, we're going to be focusing on EBS and EC2 instance store. So what is an Amazon EC2 instance store? It is the storage local to your EC2 instance. It is a non-persistent data store, which makes it a great option for TempDB. EBS volumes are redundant and offer native support for encryption. They have an SLA of 99.99%. EBS provides greater fault tolerance than the EC2 instance store. SQL Server, of course, has transparent data encryption, but it's only available with the Enterprise Edition. So if you don't want to pay the high cost of Enterprise Edition, I suggest you consider EBS volume encryption coupled with SQL Server encrypted backups. Here's a quick view of the EBS volume types. There are 4 kinds of EBS volumes. You can use the SSD volume types, such as GP2 and IO1, for higher IOPS, for your data and log files. The HDD volume type, SD1, is a great option for native SQL Server backups because it provides fast sequential throughput at a much lower cost. You can also set up a backup archiving lifecycle that incorporates EBS along with S3 and Glacier. Here are some examples of performance types you could get from different EC2 instances and EBS volumes. For instance, you could get up to 80K IOPS with EBS volumes on some instance families, and the performance scales with the instance size. Next, let's look at some high availability and disaster recovery configurations for SQL Server on EC2. So most of our customers deploy high availability and disaster recovery for their mission-critical applications. Here are some commonly used architectures. This diagram shows you a typical multi-AZ configuration using always-on availability groups. You could extend it to another region with asynchronous replication for disaster recovery. A lot of you have told us that while you know all about HA, you find setting it up on cloud difficult. And to make it very easy for you to deploy high availability solutions on AWS, we launched a new service called the AWS Launch Wizard for SQL Server. AWS Launch Wizard offers you an end-to-end guided experience for sizing, configuring, and provisioning SQL Server always on EC2. You don't have to identify and provision individual AWS resources. On the console, you simply input your SQL Server requirements, such as performance, number of nodes, etc., and the Launch Wizard identifies the right AWS resources for your needs. It presents you with an estimated cost of deployment, and you have the option to modify the configuration. And once you approve, AWS Launch Wizard provisions and configures these resources to create a fully functioning, production-ready deployment for you. It follows the AWS recommended best practices and automates the deployment in fraction of the time of what it would take someone to do it manually. It also creates custom CloudFormation templates that you could use for your subsequent deployments. You can use the Launch Wizard with all current SQL Server versions, including SQL Server 2019. And it also supports deploying passive nodes or read-only replicas for your SQL HA. So let me show you how the snapshot of how this service works. So first, you simply input your requirements, such as performance, storage, AMI, licensing, connectivity to on-premises AD, and so on. And Launch Wizard recommends the right AWS resources, such as EC2 instances, EBS volumes, etc. Then, as I was telling you before, that Launch Wizard presents you with an estimated cost. You can completely modify the resource until it meets your budget requirements. And you can instantly see an updated cost estimates with that change. Once you approve, the AWS Launch Wizard automatically provisions and configures these resources to create a production-ready deployment for you. And after deployment, as this screenshot shows, you can revisit your deployments through the Launch Wizard. In addition to the general availability for SQL Server, we recently also announced a preview for SAP deployments through the Launch Wizard. And you can anticipate that we'll continue to add more commonly used enterprise applications onto the Launch Wizard. So if you have ideas on what next you'd like us to offer, do let us know. Next, I want to talk about the Amazon FSx solution for simplifying SQL Server HA deployments. SQL Server high availability relies on shared storage for hosting databases and logs. Amazon FSx for Windows File Server offers fully managed multi-AZ Windows native file system with support for SMB transparent failover, which is a key requirement for SQL Server clusters. And the best part, you can use this with SQL Standard. Next, I'll hand it off to Tom to talk about some partner solutions on AWS.
Thank you, Pallavi. So yeah, FSx, it's great. It's a great option to be able to do failover clusters to provide that shared storage. Another way that this can be done that people have done for a few years is using Scios Data Keeper. So as Pallavi mentioned, I'm going to talk a little bit about some of our partners, and one of those is Scios. We've been working with them for several years, and if you're not familiar with Data Keeper, it works a little bit differently because this is not actually shared storage. This is something a little bit different. This is a share nothing failover cluster, because what we're doing here is replicating the storage volumes between the two different EC2 instances. But just like we would do an availability group, as Pallavi mentioned earlier, we're going to do this across availability zones because we make sure the latency is low enough to provide that capability. So you're going to have this in two different data centers. They're isolated, miles apart, separate floodplain, separate power grid, all the great advantages of being in two different availability zones. With DataKeeper, you're going to replicate that storage, and you have two different EC2 instances, so you have redundant compute and redundant storage in those two separate isolated data centers. So I often refer to this as an enterprise-grade solution, but the great thing is, because we're talking about a two-node SQL Server failover cluster configuration, whether it be with FSx or with Scios DataKeeper, you can do standard edition SQL Server in a two-node failover cluster. So right there is a huge cost savings over the cost of over the price of enterprise. Now I said two nodes, and that's true. You can only do two nodes in that failover cluster, but here we're doing a third node. So what we do here is you set up that two-node failover cluster, and you have that in one region, and then that's multi-AZ, just like you see here. But then in the second region, we're going to create a standalone SQL Server instance, and we're going to use Scios DataKeeper to do an asynchronous link to the second region. I generally recommend synchronous communication between availability zones because of the low latency, but between regions, just because of the geographic distance involved, you generally want to go asynchronous. So here's an example of multi-AZ SQL Server on RDS. And you can see it looks completely different from EC2, right? I really hope you don't think that, because it doesn't. The only difference is that icon in the middle, that's the RDS icon instead of the EC2 icon. But other than that, it's the same. And that's not really a coincidence, because RDS for SQL Server Enterprise is running an availability group. That's what it's doing. We can't use regular availability groups on standard edition. You could use basic availability groups. You can use mirroring. But the great thing about this, my favorite feature of RDS, is you don't really need to worry about how it's happening, because as I said before, this is a managed service. A great example of this I always talk about is if you're a DBA and you're responsible for setting up this two-node configuration for high availability, you get everything set up, everything's working great. 2 o'clock in the morning someday, it could be a month later, a year later, 10 years later, whatever it is, at some point, something happens to the primary, you get paged 2 o'clock in the morning, we had a failover. You check, yep, sure enough, everything failed over to the secondary. Great, I did my job, I know what I'm doing, pat myself on the back, I set everything up perfectly, right? I'm gonna go back to sleep. Except you're not gonna go back to sleep, because you're down to one node now. You don't have HA anymore. All that work you did to set up high availability, well, once that failover occurred, you're now running on what used to be the secondary, and now you don't have high availability if your primary did fail. If this is on premises, this is really bad, because you might have to contact procurement and go buy another server. And you could be stuck in this single server situation for a little while until you get this server and you get it reset up. And of course, in the cloud, if you're on EC2, you could just launch a new instance and resync and get everything set up, and maybe you have CloudFormation set up, maybe you're using auto-scaling to reset that up, but there's still a little bit of manual process to get everything resynced and get it set back up into your availability group or whatever you're using. With RDS, we have automatic host replacement. So what that means is, if that primary does fail, we're going to fail over, which obviously, I mean, that's a given, we're going to do that. But what we're also going to do is we're going to replace the original primary with a new instance, and we're going to resync it for you. You really can go back to sleep, because there's nothing you're going to do. We're going to do all of that for you, and that's part of that managed service that we talk about. And we do a lot with the managed service. We'll do managed high availability. We'll manage the backups, backing up directly to S3. We'll manage the patching of the operating system and SQL Server. But what if you want more? What if you want a read replica? What if you want to read replica without Enterprise Edition, right? Because if you're running an availability group on EC2, you could do a read replica. But what if I don't want to pay for Enterprise Edition, I still want read replicas? What if I want multi-region replicas? Well, another partner, Cloud Basic, provides just those solutions for us. So with Cloud Basic, you can do multi-region replicas of RDS. You can also do read replicas of RDS. But again, this doesn't even require Enterprise Edition because Cloud Basic is doing the work behind the scenes to provide these read replicas. All right, so we've talked about the why and the where. Right? I think we've covered those topics. So as promised, we're going to talk about how. How do I get my SQL Server instances, my SQL Server workloads over to AWS? What is my migration path like? I always tell everybody, look, just keep things simple if you can. There's no reason to overcomplicate. And the simplest way to migrate is just back up and restore, right? Nothing more complicated than that. If I got a database, it's running 24/7, my people won't mind if I'm down for a couple hours. Well, no, I'm kidding. You don't do this in a 24/7 setup, but there are a lot of systems out there that are not 24/7. There are a lot of storefronts that use SQL Server as their database. They're not up in the middle of the night or maybe on a part of the weekend or whatever time works, right? You can take that downtime, do your backup and restore. Obviously on EC2, we're going to support a native backup and restore because it's just SQL Server running in a VM. But we also support native backup and restore on RDS as well. But fine, that's not going to work for everybody. It's not going to work for those 24/7 operations. And that's perfectly acceptable. We have a solution there too. In fact, SQL Server has a solution. If you're running a 24/7 operation on premises, you're probably running an availability group. If you're running an availability group and you're running SQL 2016, 2017, 2019, it has the capability of a distributed availability group. If you're running an older version, you can extend your availability group with a single node into AWS. You could do that. But the advantage with the distributed AG is if you really need to have no downtime or as little downtime as possible, you can set up the whole availability group on AWS. You then set up this distributed availability group so that it's joining the two separate AGs. And you get everything synchronized, somewhat synchronized anyway, because you notice it's an asynchronous connection from on-prem to AWS. But then you go through a series of steps. If anyone's ever done a manual failover, you know you don't really want to do a manual failover with an asynchronous commit. It's not ideal, potential data loss. So what you want to do is you first temporarily change that to synchronous commit, check to make sure everything is synchronized, then go ahead and do your manual failover to the AWS availability group, and then you can switch that back to asynchronous. And eventually you can, you don't even need to keep the one running in the corporate data center. But now you have your availability group running on AWS, multi-AZ, all the great things that we talked about earlier. But what if that's not an option either? What if you're not running an availability group? What if you're not running Enterprise Edition? We have our own service, the database migration service. And this also has its own special features, such as the schema conversion tool that works alongside it. If you're not just moving SQL Server to AWS, but maybe you're thinking, you know what, I'm tired of paying for a commercial license. I want to move SQL Server to AWS, but I want to, maybe part of this data could just be stored, maybe, I don't know why I'm storing images and PDFs in SQL Server. Maybe I can just put those in S3. Or maybe some of this data can go to Aurora or to Redshift if it's a data warehouse, something like that. In those cases, that's where the schema conversion tool can help and make those conversions from one schema to the other. The one thing about the database migration service that some people misunderstand, they see that name, database migration service, they're thinking, but I need continuous replication. I don't want to not just a one-time migration. Well, it actually does do that as well. It can do that one-time migration. It can also be used to continuously replicate and keep current the destination with the source. And with that, I want to introduce Stephen from Liberty Mutual. Liberty Mutual used DMS for their own migration and replication. And he can talk more about that and the other services that they use as well. Steve?
Okay, thank you. Thank you, Tom. So, by way of afternoon, and by way of introduction, my name is Steve Wright. I'm a VP and Senior Director within Liberty Mutual Technology. And I'm responsible for data and analytics within one of the two main strategic business units. For those that don't know, Liberty Mutual is one of the top 5 P&C companies globally. We have combined revenue of around about 40 billion, employ 50,000 people globally in around 30 different countries and territories. Now, Liberty Mutual is trying to keep up with the times, and early in 2018, we had a restructure, and we brought together a number of our business segments into 2 strategic business units. One of them was really focusing on our auto and home and small commercial units, while the other one was focusing on our medium to large scale commercial business and Lloyd's of London, and that's the group that I support. Now, one of the challenges we had was, as we brought together all these different business segments, they all had different technologies. And this really doesn't tell you the story. We are running hundreds and hundreds of SQL servers just within inside the data space and BI analytics environments. But what we have here, we have data spread across SQL Server, DB2 mainframes, Oracle, Teradata. We have Informatica in here. We've got all the Microsoft toolset. So we were faced with this challenge of how do you try to bring all this data together to really provide a holistic global view of the performance of GRS, which is the unit that I support. And more importantly, how do you start bringing data together to support our data scientist community? Because one thing that we realize in the insurance industry is data is key. And everybody says data is key, but it's trying to extract the information from that data, make it available to the data scientists. And what we're finding, along with a lot of other industries, is a lot of our data scientists or analysts are spending about 80% of their time just trying to identify and collect data. So what we wanted to do was find a way to bring it together holistically so they could really spend their time analyzing it, creating models, rather than trying to find the data. So we spent a lot of time coming up with a data strategy, and then realized also we needed a cloud strategy. Now, one thing you'll notice on here is that we are heavily dependent on Microsoft. So we started looking at the various cloud providers. And one option we had was maybe we go multi-cloud. But then we felt, well, no, it makes more sense to bring all of our data solutions into one cloud provider, hence we partnered with AWS. But that then gave us a challenge. As we're so big in the Microsoft space, especially with SQL Server, how do we go about running our SQL Server environments, our data stacks, inside AWS? Because a lot of these environments were pretty new. They were only about 5 years old. And so they were well architected, very efficient, and very performant. In addition, because we're a global organization, we are heavily regulated. So much so that, only certain people can see certain bits of information. And even people sitting next door to each other inside the office can only see certain information. So we heavily use row-level security inside SQL Server via Active Directory to ensure you can only see the data that you're allowed to see. We're also a very large global Power BI user. We've got our own premium Power BI environment set up with our dedicated compute and resources. And we wanted to ensure we maintain that, because one thing we didn't want to do is disrupt our user base and say, guys, you've now got to rewrite all your Power BI dashboards. We also had a fully automated CI/CD pipeline based on Azure DevOps. And again, we didn't want to go around and have to rewrite that from scratch as well. And we also wanted to reduce cost and run rates. Reduce our support and run rate costs. So these were some of the key challenges we had that we had to look into to say, okay, how do we go about doing this? And I set my team the challenge to say, tell me why you cannot run SQL Server or our SQL environments in AWS. So at the beginning of this year, we looked at one of our environments, we took a thin slice, and we said, okay, we're going to prove this out. And that's exactly what they did. They were able to prove it out. It was successful. We then went to pilot. The pilot is just about finishing now. And we're now looking to start rolling this out into production. So I just want to spend a few minutes now explaining to you a little bit about how we went about this and how we've configured our SQL Server environments inside AWS. And as I said, this is aimed more at our data and BI stack environments. Our front-end applications are looking at things slightly differently. So the first thing you'll notice, I just want to take you into the slide, is the two main SQL Server stacks there. As I said, we have hundreds and hundreds of SQL servers. So we took the opportunity to consolidate them into two key areas. And as Tom said, we leveraged RDS really for our landing and staging areas. And this made total sense for us. So we're fully leveraging all the capabilities that Tom has just mentioned. But then, if you remember, I mentioned at the beginning, our EDWs, our data warehouses and marts, we had to use row-level security. Now, inside Liberty Mutual, we're quite strict on our security protocols, and we don't make use of AWS's managed AD capabilities. So we had to leverage our on-prem AD capability inside this environment. So hence, it made sense for us to use EC2. So again, we consolidated all our environments, our SQL servers, I should say, and set up an EC2 environment to support that side of the house. Then inside the analytics side, you'll see that there's four main boxes there. Again, at the moment, AWS don't have natively all of the Microsoft BI stack available in RDS, so we've leveraged them within EC2. But again, what we've tried to do is to leverage this as much as possible, so we have the flexibility to spin up and spin down the environments where necessary. So looking at the two analysis services query boxes at the bottom, SSAS query, SSAS processing, the query box is running 24/7, while the processing box is spun up as and when required. And that's the service, that's the analysis service. It actually generates the cubes. Then once it's generated, we pass it across into the query side of the house, which makes sure there's no downtime for our end users. And the same is true with SSIS. With SSIS, we spin this up and spin it down as and when required. For some of our environments, we run SSIS once a day. Sometimes we run it every 15 minutes. But as I say, we're making the benefit of AWS to achieve that. With respect to our Azure DevOps, we set up a Bastion host. So we can run PowerShell scripts there to control that for us. And then reporting services is on another EC2 instance there. And this is all working, extremely well and well hung together. A question that I get asked a lot is, well, what do you do about your Power BI? Because Power BI is on Azure. Yes, it is. But what we have set up inside Liberty Mutual is a pipeline between AWS and Azure so that we can stream data between the two. And we've been able to set up inside this environment a Power BI gateway sitting on EC2. We could have done it on-prem, but we thought it makes sense to put it on EC2, which communicates and sends traffic out to Azure so that we can then make use of Power BI, our premium Power BI environment, and it's actually then reading the data from our analysis services cubes and our reporting services side of the house, and also our EDW and data marts. And what we're finding is that it's very performant, and we're getting really good results through that pipeline. Now, going back though to the beginning to Tom's point before he introduced myself, DMS. So we thought, how do we get our data from our on-prem, a lot of which are SQL servers, our applications, into AWS? And we looked at things like SSAS, we looked at SQL Replicant, we looked at Attunity, and we looked at DMS. We found between Attunity and DMS is a PaaS. And we wanted to really benefit from that rather than having to worry about setting up Attunity and on IaaS. That meant if you had any issues, we could pick up the phone, speak to AWS, and they could support us. We looked at SSIS, but what we found was DMS was 3-4 times faster than SSIS. Give you an example, to move 10+ million rows across the pipe, took DMS about 15 minutes. It took SSIS about an hour. So we've kept with DMS. We did do a DMS to do our initial data load, but we're also doing it for the replication. So any changes that happens on our source systems, DMS will replicate that across into our landing and staging area on the SQL Server there in RDS. Now, as I said, this is about to go live. As part of our testing, we did put production volumes through this, because one of the things we wanted to prove out was, is this cost effective? Is this more cost effective than being on-prem? And we were pleasantly surprised that at the moment, our estimation is this is going to be 50% cheaper than running a similar environment inside our current on-prem data centers. So obviously, you know, great savings are going to come our way through this. So in summary, what did we learn? What did we do? So you can see here the requirements we had. We wanted to maintain our Microsoft BI stack. We didn't want to have to refactor it. It was running. It was fit for purpose. Why change it? We wanted to limit any refactoring. We had to have that Active Directory rollover security in place. We had to support our global BI users. We wanted to reduce our support costs, and AWS was our cloud provider of choice, and we wanted to leverage that. The outcomes, as I said, we've proven out we can migrate. We've maintained our architecture. We call this a lift and tweak. There was a little bit of tweaking we did. It wasn't a complete lift and shift, a lift and tweak. We have leveraged AWS's Microsoft capabilities. It's been cost effective, it's scalable, and more importantly, we now have a playbook that is going to enable us now to rinse and repeat across the remaining SQL Server environments we have within my data space to move them from on-prem into AWS. And that's really going to be a focus for my group within 2020. We feel we can do this in the next two quarters. We're also, keeping close tabs with AWS so that as more and more Microsoft objects are available in RDS, we'll migrate across to those. We're then going to look at that landing area, that first RDS SQL Server environment you saw, looking to replace that with our S3 data lake. That's part of our ongoing strategy. And then over time, we can just sit back and decide, do you want to carry on being a Microsoft shop, or do you want to start moving across to some of the more native AWS capabilities they have? So that's our story. We've been very pleasantly surprised and pleased with the progress we've made. AWS have been very supportive in helping us through this journey. And with that, I'd like to hand over to Tom.
It's always great to see those real world use cases. I could talk all day about what I refer to as the building blocks, right? EC2, RDS, EBS. I'm going to talk a little bit about some more, but seeing how it all comes together to solve a customer solution is, as Steve said, to save them, 50% on their cost. Bringing it all together, it's not just about one piece, right? It's a combination of, they're using EC2 and RDS and DMS and all these other things coming together. It's a great story. Appreciate that, Steve. So finally, we're in the last chapter here. As I said at the beginning, SQL Server's it's not a fire and forget, right? You gotta keep at it. This is true whether it's on EC2 or RDS. RDS does not mean you don't need a DBA. It means you don't need somebody to manage your patches and your backups, your high availability. I don't know about anybody else, but in my previous jobs as a DBA, those were not the most exciting parts of the job. I like the performance tuning pieces of it and really digging in there and helping people write better stored procedures and figuring out how we can, maybe if we add an index here, maybe we switch to a column store index or something like that, right? All those type things, that's all still true. That's all still there. Now the DBA can spend more time doing that because you're not bogged down with, did you remember to do the backup on these 800 different databases, and because the job you had running failed, and we're going to manage all those backups, the patches, and even, like I said, the high availability. So what are you going to do? Well, first, obviously, monitoring, right? You got to be aware of what's happening. And when you talk about monitoring in AWS, you can't not mention Cloudwatch, right? That's our ubiquitous monitoring tool. It's got everything in there, all of our services. And obviously, SQL Server, here you can see RDS and some of the things you can find there. We also have enhanced monitoring capability with RDS. And even deeper than enhanced monitoring, we have performance insights. Performance insights, as you can see here, you can drill down and you can look at, okay, well, which wait states are potentially an issue, which SQL Server statements are taking the most time, and really get a better feel for what is most impacting my performance. Sometimes people want to go even deeper than that, and if you're familiar with third-party tools, a common tool is SQL Sentry. Sentry1 is another partner of ours. And what's great about SQL Sentry is it is an agentless tool. Because it's agentless, it can work with RDS and EC2 just as well. In fact, this is an example of SQL Sentry monitoring an RDS instance and looking at the different performance indicators. As I said before, there are other services. You could go to an entire session, watch an entire 1-hour video just on Systems Manager, for instance. I know because I've seen some of them and attended some of those myself. CloudTrail, CloudFormation. CloudFormation is great for that. I mentioned it earlier in terms of that infrastructure as code, right? You don't want to have to manually recreate everything all the time. Having something like CloudFormation makes that much easier. Auto scaling, like I said, Systems Manager, License Manager, all of these and more. They're all great services to build that complete picture for not only having SQL Server, you get it on there, but then continuing to maintain it and achieve optimal performance. I understand that that's a lot. There are a lot of services, a lot of different areas of technology. Maybe you're not an expert on all of that. Maybe you're looking for an expert. Well, with AWS, we have our competency program that you may be familiar with. We have competencies for things like migration, IoT, security. We also have a competency for Microsoft workloads. And within that, we have a category for SQL Server. You can see at the bottom some of the partners I mentioned. One partner I didn't mention in the slides was Data Sunrise. But if you're looking for a solution around security and data masking, I definitely recommend looking into what Data Sunrise offers. But you can see also Cloud Basics, Sentry1, and Sios I mentioned in the presentation. They are all ISV partners in our competency. The other partners you see listed above them in the slide are all consulting partners also in our competency. Every one of the partners in our competency has, has been audited and vetted for their expertise, and in this case, their expertise with SQL Server on AWS. So if you are in that position where you do want to make that move, you do want to migrate SQL Server to AWS, or maybe you already have SQL Server on AWS, but you're looking for more expertise in managing it, monitoring it, I definitely recommend reaching out to these partners. And with that, thank you for your time. If you have more questions, you can also reach us at Microsoft@Amazon.com. Thank you very much.